next parts that I am going to attack will be the chuck jaws to finish out the 4-jaw chuck. Now the material that they give you with the kit is 375 wide, which means these jaws will have to be positioned on this bar this way, stacked. The only thing I don't like about that is this little 061 slot on the side. That's about 1.5 millimeters right there. Just under, let's say 0.9 millimeters, 0.85 millimeters deep. The only thing I don't like about that is you're going to have to make a ladder bar out of all of these little slots on both sides in order to accommodate the 485 height and the 375 stock utilization. Well, not a big fan of that. I'm going to use another piece of material, and I'm going to do these inverted. And by inverted, I mean this way. I'm going to use a slitting saw, run the slitting saw down the full length of the part, both sides. That way I know that they're on the same plane. There'll be no guesswork. Slice it, go around the back, slice it again, and I will effectively have this profile, the full length of this part. At which time you can do whatever you want, but I think my course of attack here is to split this in half and then section it off at the 485 height. That way I can bump end to end and just do all the pockets, all the little steps and stuff while holding two pieces. Final up, section it off into 4 parts and bring in the height. So that's my plan. I am going to try to do this slot with a slitting saw, with an 051 slitting saw. And I'm going to walk it 0.010 of an inch vertical to achieve the 061 slot width. Now, if your saw is not ground correctly or it's got some bad teeth on it, when you try to do something like this, all it's going to do is deflect and frustrate you. But it's a carbide saw I'm using, and I think I'm going to have some pretty good luck with it. Smaller diameter saw, the better for something this tight. And there we go. 1018 in the machine, about 3 inches long. Good. First step in the process, put the slots all the way down the front and rear sides. Going to turn the machine on until it scratches the top. Move the blade down the thickness of the blade, and from there you can start with the dimensions that you need to hit. I need the top of this blade 70 thou below this surface, and I need a slot that's 62 wide. Do that. Next step in the process is to square up both ends of the oversized blank, cut it into manageable pieces so that you get 2 jaws out of each piece, and then square up the ends of those pieces. As I may have said before, the ideal piece of material for this would be 3/16 by half, but I have 3/16 by 1, so I'm going to work with that. Do yourself a favor, and while the piece is big, square up the ends. This assures you a nice clean cut and a good rigid setup. Overall length really doesn't matter, just make sure it's long enough for 4 pieces. For ease of downstream processes, it's a good idea to have a stop in your vise now so the blanks I just sawed out of the larger plate register against the stop. Make both pieces the same size. The ideal material here would be 3/16 by ½ inch. That would be absolutely perfect. I don't have that, so I'm going to have to go back to the bandsaw again and rip these. To maintain the accuracy of the part in downstream operations, make sure any blank that you're going to prepare that's one of a set, make sure all the blanks are the same length. Both of my jaw blanks are cut down to just over a ½ inch now. I'm going to sandwich them up, and we're going to cut all 4 at one time. There's 2 pieces per blank. They are back to back at this point. And stand them up and just mill the top off until they're the height that you want them. Then we can put the stop back in and work on it from there. And anytime you can kill 2 birds with 1 stone, figuratively speaking, of course, do it. You'll notice, like I always do in most of the milling that I do, the rotation of the cutter is driving the material into the part, not to the outside. If you mill across the top of the part with the cutter spinning clockwise, it's going to roll the burr over to the outside. If you can drive the burr to the inside, it'll shear it off. Makes it a lot easier to deburr it. Burr is almost non-existent on the back side. Leaving them in this setup, we're going to set a stop. Flip the parts over and put a notch across the bottom that will trap the set screw in the jaw body, and the set screw will drive back and forth against the undercut we're going to put in the jaw. I know there's been some confusion as to how that works. First time I've seen it as well, but I'm going to go with the design as it is with minor dimensional tweaks, but the basic design will be the same. And although, yes, you could line them up and do them all at the same time, I think I'm going to do them one at a time just to be sure. One of the benefits of working with a blank of a known length is that you can create a feature from the opposite side of where the part is registered. If the parts vary in length, then the features will migrate accordingly. Since we're making a lot of pieces, or we're making 4 pieces out of 2 blanks, having those 2 blanks identical size, we can trust the features that we put in if we're banking from a stop that's not against the surface that the feature is dimensioned from. So if this part were to get shorter, this slot that I'm cutting right now would get closer to the end of the part. The opposite of the stop, that is. That's the notch we're looking for, and that is the groove that is going to capture the set screw and allow this jaw to move once it's installed. This is a 187 wide cutter. That's just about 5 millimeters, just a little under 5 millimeters. And we're going about 60 thousandths of an inch deep, 1.5 millimeters deep. Next feature in line will be the outside steps on the jaws, and I'm going to position these so that the jaws are facing each other. I'm coming in from the outside of the part with the cutter, and if you look closely on the print, it calls out for a 250 radius in these cutouts right here. So that's what the little dotted line is. And technically, the cutter will make contact with the jaw and go in farther than the 125 steps called out on the print, because that is shown to the high side of the jaw and not the undercut. But I'm going, when I make contact, I will watch the cutter profile as it enters the top of the part. As the full moon makes contact with the outside edges of the part, which will be the hard line, that's where I'll set my 0 and start my cuts from. I'll try to get a good shot of that for you so you know what's going on. But for what this is, if you were to just make contact with the edge of the part and come in 125 and 250 respectively, it wouldn't change a thing. After those bottom scallop gets done, this is clearance for the driver that closes these jaws, and then we're just going to cut them off, stand them up, and put about 1 billion chamfers on them. That's probably going to be the longest part of the whole op. All right, let's get this thing on a tripod, throw some chips. I am using one of my infamous bridge setups for this because the stop rod I'm using is thicker than the part, and I know I'm going to be relieving off the corners of this block, so I need to hit the stop low. Parallels form a lift for the pressure pad. Pressure pad actually touches the part and not the vice jaw. If I were to try to close the vise on this right now, I would squeeze the rod and not the part. So this is going to overcome that for me, and it's lifted and elevated with the second set of parallels. Pretty simple. This is a 1/2 inch cutter. Let's do the do. Right at the point where the end mill is going to make contact with the part, try to keep an eye in there, and hopefully the shadows won't get to you too bad. But watch for the half moon shape to consume the upper surface right until it touches the edges. Now I'm going to do it on this side so you know what I'm talking about. I want to create an arc that basically goes from corner to corner without wiping out the corners. That will be the step back in the print. So it's the corner dimension I want and not the actual cut. Well, I want them both, but can't, you know, let's see what happens. All right, there we go. Put something on there you can see. If you need to use a loop or something, go ahead and do it. The steps that are called out on the print on the jaws have a 1/4 inch radius. That means it's a 1/2 inch cutter, 12.7 millimeters. And I'm going to bring it down. I'm going to try to position the cutter such that the diameter of the cutter cuts between the 2 points on the edge of the material, so that the resulting sharp corners technically will be at the 125. Now that small arc that I just cut right there is only about 5/1000ths into this part, and for all intents and purposes you could just hit the numbers on the print as such. You're going to see me make double passes on this because you can see the material is bulldozing in front of the cutter. It's starting to raise. That's going to give you an additional surface to deburr. So go back over top of it, and as you make your final pass on each step, you will remove that burr. And do be careful when you create a corner like that. It is razor sharp and will cut you in a heartbeat. And you won't get a Christmas card either. I've been waiting for years and it just never happened, so be careful. This is a 4-flute carbide ball nose, 1/8 diameter, 1/16 radius, 4-flute cutter. And if you do not have a ball end mill 1/8 diameter, you can do this with the jaw standing up and use the edge of a 1/8 standard end mill to do the bottom trough I'm doing. It's very superficial. It's only 15/1000ths of an inch deep, 1/64th imperial, or about 1/3 of a millimeter or less, actually. About considerably less. Well, let's just call it 1/3 for now and get it done. Full length of the part, and this is only clearance for the driver key. This particular feature is the feature that allows the miniature chuck key to rotate without the high spots of the hex hitting the underside of the jaw. So this is basically clearance. The flat on the bottom of this part is not really important for function, but it may be for locating the part for future operations. So make sure you leave something. We're about 15,000 on the bottom of this part. Make sure you increase the RPM on this cutter because the center of the cutter is not moving nearly as fast as the outer edges of the cutter are. Very much like if you were on a merry-go-round standing in the center and somebody was on the outside. If you were spinning with them, you'd be spinning a lot slower if they were running around the outside of the merry-go-round trying to keep up with you. Same thing. Fairly conventional setup for the chamfer on all 4 corners, all 4 vertical corners. Part is in the vise up against the stop. I'm using a 45-degree cutter. And whatever kind of stop you use, make sure it projects far enough out that when you flip this piece over, that the stop doesn't go in the notches. And I'm using the other part as the offset in the jaw, so I get a nice bite. Simple setup. As with any operation, there's probably a half a dozen different ways to do this, but you have to weigh the setup time versus the actual machining time, and sometimes it's just not worth setting up additional stops or registration points or aligning the part. It's just easier to put the part in there, flip it over, and have at it. Standing vertically, we could do both sides in the same setup, but then again, you'd have to worry about making sure it was sitting in the vise square, and that would take time to do. This is just quicker to set it up this way and go for it. Print called out for 062, I went 055. After the first side chamfer up, your part should look like this. or better. So we're going to put these across the bandsaw now, split them right down the middle here, put them back in basically the same setup, bring them to length, and put the final chamfer on the tall side. There's an awful lot of places here that burrs can hide, and if you have one burr on these things, it's not going to go together with your chuck body, so look them over real good when you're done. This part is getting exceptionally difficult to hold, so we're going to stand the tall side up on a parallel. And I really did want to side mill it because I like to finish with a side mill much better than a bottom mill like this. But I roughed these down to about 5/1000ths over, thinking I was going to lay it flat, and just didn't like how much meat there was. Didn't want to squash it, didn't want it to pull out. So we're going to go this way, and this is also a good format for putting the chamfers on as well. Make sure you leave the part sticking up vertically out of the jaws, sufficient for your chamfer operation. Keep your fingers crossed on this one, guys. Once I got these parts bandsawed apart and roughed down to almost net shape, I realized that the amount of material left over just wasn't cooperative for side milling, so I'm going to stand these up. Now, of course, when you have multiple parts like this, you could put them all in a row and close the vise and do them all at the same time. To do that is a really good idea to put a couple sheets of paper on the movable side jaw to take up any deviations in the thickness of the material, or cardboard or something. But I got to tell you that with so many hours into these parts right now, and I do have quite a few hours into them, having one pull out and blow up would just be a heartbreaker. So I'm going to take the extra time to do them one at a time, and that way I can be sure at the end when I'm done I have 4 good pieces. Starting over and making one piece from scratch would just not be worth it. It would be a really good idea to make sure that the machine is zeroed to the center of the part. That way your movements on your y-axis are exactly the same for the chamfer front and rear. Make sure everything clears before doing anything. And that is close. I like it. I've had my y-axis zeroed since the trough cut in the bottom. I'm going to run a test cut and see what it looks like front to rear with the same value. This is the last operation on these guys. I am relatively excited about this. Can't wait to put this thing together. Now, as I had mentioned, the y-axis is 0, so the chamfer values that I'm looking for when I move the table should be the same front to rear. And sometimes it's a little hard to see around the back, so I use a dental mirror to get around behind the back of the part to watch when any burrs go away, and that's what I've achieved right there. Take a look at the DRO, take a look at your dial, and know what your value is. Hit that value, and then pull the part out, and give it a good look. If there's an adjustment to be made, tweak it a little bit. That's what I just did there. That's why I moved so slow. I set the center about 1/1000th off. Quick bench measurement, quick visual, and once you're pleased, return to the setup, run all 4 pieces. If the stock is consistent across all 4 pieces, this particular feature should be consistent across all 4 pieces as well. Now remember, I went a little bit less than the print called for, just because. Now, as far as the inner grip chamfers that I'm putting on right now, the bigger the chamfer you leave on there now, the larger the part minimum will be on this particular chuck. If this came to a point, you could technically hold a human hair, but as that flat is bigger, the minimum part that you can hold also gets bigger. So dealer's choice, you call it. Now you have to bear with me, something this small is going to be very tedious to put together without getting in the way of the camera. can tell you that this video series is going to give me a whole new respect for Chris over at ClickSpring and his video ability. First thing I want to do is just stick these jaws in here just to get a look at them, make sure all the burrs are off, everything fits. Man, I wish you could see me smiling right now. I'm grinning ear to ear like a little kid. If it doesn't fit, don't push it. Gotta be a burr. Well, that's what we're shooting for. That sure looks cool. All right, let's see if we can get the screws in. It'd be awesome if that happens. And the whole secret to getting these screws in is to engage the jaw partially as such. Get the screw down and in and let it pull the jaw into position. Now that sounds good on paper, right? Let's see what happens. Get it into the cutout. Look at that. Yep, loving it. All right, lather, rinse, and repeat, people. 3 more times. Don't be getting too excited till money's in the bank, right? Let's see what happens. I love it. For now, I run them flush just for yucks. These are 1032 1/4" screws. They've been cut down from 1/4" long. They're 185 long now, and that is so that they fit in the groove in the bottom here. So with this design, I would not suggest putting too much torque on these jaws, because if you start to roll these threads over on these little screws, because of the way it's designed, you might translate the damage to the chuck body, so be delicate. Oh man, that is just like butter. Beautiful. Oh man, that's money right there. Let's get a better camera angle for you. Functional 4-jaw chuck. I can't believe how small this thing is. Gotta say, if the rest of this model makes me as happy as making this 4-jaw chuck did, I am going to be a very happy person by the time this is over. The one thing I will do, never locate anything that you want to run concentric on a thread. Just don't do it, because threads are inherently not precision location devices. Therefore, you know, squeezing stuff together. I will put this back in the machine, and I'm going to put a recess on this so it locates on the diameter that I will add to the spindle nose. I do not want this chuck to locate on those threads. I want to locate on a hard feature, and that's exactly what I'm going to do. All right, there you go. Miniature 4-jaw chuck in the flesh. I hope you enjoyed watching that as much as I enjoyed doing it. All right, guys, that's all I got on this piece. Thank you very much for watching. Stay well. Joe Pye, Advanced Innovations in Austin, Texas. Hey, closing note on this one for all of you that hung in to the very end. Got a t-shirt order in the works. So if you're into any AI swag and you want to take a look at what we got coming up, leave it in the comment line to give me some idea how popular they will be. 4-color shirts, very nice. I like the way they're going to look. All right. There you go. Thanks. Stay well.